Hi everyone. So today we are going to learn about nitrogen bases. So as we all know that DNA is a very important structure present in our nucleus, and then DNA is made up of uh, a sugar, a ribose sugar, a phosphate, and nitrogen bases. And in this video, we're going to learn about the structure of nitrogen bases and how they are going to form bond with one another. So let us start. So nitrogen bases can be classified into two types, purine and pyrimidines. When we talk about purine, there are two nitrogen bases. The first one is adenine, and the second one is guanine. In terms of pyrimidines, we have uracil, we have thymine, and then we have cytosine. So if I want to make a shortcut, I can say that this is AG and this could be CUT, cut, cytosine, uracil, and thymine, right? So now let us see the structure of pyrimidines first. So CUT. So I'm going to start with uracil. Okay, so the structure of uracil looks like a benzene ring. And then I'm gonna remove this part. I'm going to add nitrogen over here. And this ring is actually a heterocyclic ring because it contains atoms other than carbon. All these other positions are filled with carbons except for this N and then this N. So how are we going to number it? So we are going to take a simple clue from this D. So pyrimidine has a D, so we'll start numbering the atoms from downwards. So this is 1, this is 2, this is 3, this is 4, this is 5 and 6, right? In the second position of uracil, we have an oxygen group attached. In the fourth position of uracil, also there is an oxygen group attached. So this is the structure of uracil. So uracil can also be written as, let me write it down. So uracil could be written as uracil, this is uracil, 2,4 dioxypyrimidine. I'm not going to write the full name. So because it has 2,4 oxygen present in the 2 and 4th position, so it is named as 2,4 dioxypyrimidine. Let us see the structure of thymine. Thymine is also very similar to uracil. It's like, it looks like a brother. So we're gonna number from downwards. 1, 2, 3, 4, 5, 6. I'm not gonna write the number. So in the second position, there is an oxygen. In the fourth position, also there is an oxygen. And in the fifth position, this is the fifth position, right? We're gonna have a methyl group. So thymine, the structure is thymine. Does this particular part look like uracil? Yes, all this part looks like uracil except for this one, right? So this is the structure of thymine. Now, thymine can be written as 5-methyl uracil. Do you think I can write this? Yes. Okay, so let's do the other one remaining, that is cytosine. Cytosine is, I'm going to draw it small. So N and then N over here as well. This is also a heterocyclic ring. In the second position, we're going to number it from downwards only. 1, 2, 3, 4, 5 and 6, right? So in the second position you have an oxygen, and in the fourth position you have a methyl group. So this is cytosine. What do you think I can name it? Can I name 2-oxy, 4, sorry, I'm writing methyl, 4-amino pyrimidine? Can I write it? Yes, of course. Okay, so these are the structures of the pyrimidines. The first one is uracil, the second one is thiamine, and the third one is cytosine, right? I've written the word over here so that you don't get confused. So this is cytosine. I'm just going to write it with another pen so that you don't get confused. Okay, so any other color? Okay, I'm going to take this. This is cytosine. This is thiamine. And this is uracil. Okay. Now let us try to draw the structure of purine. So purine is very similar to pyrimidine. So if you know the structure of pyrimidine, purine is just like, very easy. So let's start with purine. So I'm going to draw the same structure. The benzene ring. I'm going to put N over here, put N over here. And then, now, in the structure of purine, there is an extra heterocyclic ring. So in the structure of pyrimidine, we had only one ring, but then in purine, we'll have two rings. So we'll have an N, we'll have an N, and then we'll have two rings, right? So this is adenine. Okay. How are we going to number it? We are going to number it with the usage of this U. So U means like up, right? So in pyrimidine, we numbered from downwards, like to upwards. But in purine, we're going to number it from upwards. So we're going to number it like 1. This is the like the nitrogen which is present in the upward direction. 2, 3, 4, this one, 5, this one, 6, right? And then 7, 8, and 9, right? In the sixth position of adenine, we have an amino group present. Now, can I say, how can I name this compound? Can I say that it is 6-amino purine? Yes, I can say that, right? Okay, so let's go to the structure of guanine or guanine. So everything is like same, everything, the structure, the ring structure, everything is same. This one, their structure is same. These structure is same. This is like the nucleus of the purine. That is like the basic structure of purine. So let us draw guanine. So guanine looks like adenine. We're going to take N, 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 and then we have N, N, 4n, right? In the pyrimidine we had 2n and here we have 4n. So we're going to number it from upwards because it is purine. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now, in the sixth position, in adenine, we had an amino group. But in guanine, we'll have an oxygen group attached to the sixth position. And in the second position, we'll have an amino group. So this is the structure of guanine. Can I say 2 amino 6 oxypurine? Yes, of course I can say that, right? So now we know the structure of purine and pyrimidines. Let us see the hydrogen bonds. Okay, so when we talk about a DNA, this is a double helical structure of DNA, and then the DNA is made up of, as I told you in the first place, it is made up of a phosphate, it is made up of a ribose sugar, and then it is made up of a nitrogenous base, right? So these three things are very important in formation of DNA. Now, when we see this double helical structure of DNA, we all know that we have seen in like pictures and in textbooks and diagrams that, you know, there is like a bond present out here, like a line present out here, right? So what exactly is this line? This line is the hydrogen bonds. So these are the hydrogen bonds, and these hydrogen bonds are formed between purines and pyrimidine. So we are going to talk about this hydrogen bond and the exact position of the hydrogen bond that will be formed between the purines and the pyrimidines. Now you always have to remember that hydrogen bond is always formed between a purine and a pyrimidine. That's why A is a purine. It always forms bond with T, and there is a double bond. This is a double hydrogen bond. G is a purine and C is a pyrimidine. It always forms bond between these two, and there are 3 hydrogen bonds, right? This is in case of DNA. When we talk about RNA, in RNA, adenine always forms bond with uracil in terms of RNA. But when we talk about this guanine and cytosine, this is similar in DNA and RNA both, but only the distinct part is that uracil. Uracil is only found in RNA and it forms bond with adenine. So I hope you're clear about this one, right? So now let us see how hydrogen bonds are formed. First, let us see adenine and thymine, before we understand the hydrogen bond, how is hydrogen bond formed? So hydrogen bond is actually, whenever a hydrogen is attached to an electronegative compound. For example, if I say a nitrogen is attached to a hydrogen, right? And if any of the electronegative compound is present on the other side, fluorine, oxygen or nitrogen, there is a possibility that this hydrogen will be able to form bonds with these atoms. So this could be either nitrogen, this could be either oxygen, this could be either fluorine. But here in terms of DNA, we are talking about nitrogen attached to the hydrogen. So specifically, I'm talking about nitrogen. So if you see out here, in the sixth position, if you see out here sixth position and then the fourth position, there is a possibility that there is a hydrogen bond can be formed between these two, right? Yes, there is a possibility. Now when we talk about this nitrogen and this nitrogen which is attached to another hydrogen, there is also a possibility that there is a formation of a hydrogen bond. So I'm talking about N1 and N3. This is actually N3, it is not NH3. I'll just make it so that you don't get confused. So this is actually N, and then there is a hydrogen bond over here, right? So there is a possibility that there can be a possibility that hydrogen bond can be formed between these two. Now what about this one? Do you think hydrogen bond can be formed between this one? Can you see any hydrogen atoms? There is no hydrogen atom over here. What about this one? No, there is no hydrogen atom over here as well. So there is no hydrogen bond formation. So in adenine, there is two hydrogen bond, 1 and 2, adenine and thymine, right? So the bonds are formed between which atoms? The first one, if you try to see, I'm just going to rub this. So if you are going to see the sixth position is forming bond of adenine, is forming bond with fourth position of thymine, and first position is forming bond with third position, right? So these are the atoms which are involved in the formation of hydrogen bonds. So let us see in guanine and cytosine. So there is two hydrogen bond, right? I hope you can see out here there is one hydrogen bond, two hydrogen bond. Here there is no hydrogen bond because there is no H present. There is no H attached to any electronegative atom, so there will be no formation of hydrogen bond. Let us see out here. Out here, I see a possibility that the sixth position of guanine can form bond with fourth position of cytosine. Yes. Out here also I see that position 1 can form bond with position 3. I hope you're able to understand 6 and then 4, right? Okay. Out here, you see that 1 is can form bond with 3. So one position of guanine can form bond with third position of cytosine. Another one is second position of NH2 can form bond with second position of O. Yes, there is a possibility. So let me first draw this one, the second one, and then this hydrogen can form bond with this electronegative O as well, right? So how many bonds are forming? 1, 2, 3, right? The last one is formed between second position of guanine and second position of cytosine. So can I write 2, 2? I hope you're able to follow, because in guanine, it is a purine, so we're gonna number it from upwards. So 1, 2, 3, 4, 5, 6, and then 7, 8, 9, right? In terms of cytosine, we have 1, 2, I hope you're able to follow, 1, 2, 3, 4, 5, and 6, right? This was in same in adenine and thymine as well. So this is adenine as a purine. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Out here 1, 2, 3, 4, 5, 6. So I want you to remember a code. If you ever get confused, you can always remember this code. That code is that particular code is 2, 1, 6, 2, 3, 4. Right? I'll just use different colors so that you don't get confused. So 2 forms bond with 2. 1 forms bond with 3, and then 6 forms bond with 4. So this we have to understand. So when we talk about guanine and cytosine, these are the positions. You have to remember all the 6 numbers. And then when we talk about adenine and thymine, you just have to remember these 2 numbers. You just have to remove the 2 because in 2 we didn't have any NH group present, right? Let's just see. Oh my god. Yes, in the second position, this is the second position, right? This is the second position. So in the second position, there is no one like who can form bond. So this nitrogen cannot form bond because it doesn't have an H, and here also we don't have any H and electronegative atom, so no formation of bond. So I hope you're able to understand the basics of amino acid basics of nitrogen bases. I hope you're able to I hope you're able to I hope you're able to draw these structures now, and then also understand how hydrogen bonds are formed between all these purines and pyrimidines. So if you like this video, please like, share and subscribe. Thank you so much guys for watching. Hi everyone.